Hello, and welcome to today's webinar. My name is Tyler Reed, and I'm the manufacturing specialist here at GoEngineer. I want to thank everybody for tuning in today. This is a continuation of a series that has been quite popular so far, and I've had a lot of fun putting all of the examples together, and this webinar was no different. Today's topic is jigs and fixtures. Plan on 20 to 30 minute presentation on jigs and fixtures, what they are, why they're being 3D printed, and then we'll go into a variety of user cases that I came across in my research. Normally we have a live Q&A session at the end of these, but I'm a little strapped on time today, so please hold your questions till the end, and then go ahead and send them to me in an email or write in the YouTube comments if you have them. Jigs and fixtures. So let's define our terms here. A jig or fixture to me is a tool that's used during the manufacturing process to provide repeatability, accuracy, and because of those two, interchangeability in the parts or the processes. Throughout this webinar, I will probably use the words jig and fixture interchangeably, and I will probably use them incorrectly as well. I've never differentiated between the two, but while I was putting this together, I came across the definition of the two and I figured I'd share it. So a jig differs from a fixture because with a jig, the workpiece moves and the tool is stationary. While a fixture, the workpiece is fixed and the tool is in motion. So I think most of the examples we're going to cover today are actually fixtures, but don't hold me to it. Jigs are something that are used to simplify complex processes. They've been used by tradesmen for literally thousands of years to take a job that normally requires a very highly skilled person and simplify it to the point where somebody can pretend to be a highly skilled person. They can produce output that is equivalent to a highly skilled person. So I use jigs and fixtures all the time. I'm a weekend warrior in the garage when it comes to metalworking and woodworking, but by putting in a little bit of effort into creating some jigs and fixtures, I've been able to put together some projects that came out looking pretty good, a lot better than they would if I hadn't put that time in. I'm sure a lot of people out there can relate. Jigs and fixtures improve productivity by creating a consistent scenario and allowing somebody to assemble or complete a task precisely. They also increase the safety of workers by removing a worker from the vicinity of the action. Basically, a jig or a fixture acts as one extra step or one extra link between what can cut you or what can hurt you and a person's hands. So I just mentioned jigs and fixtures have been used for a long time by highly skilled people. Why would we 3D print these? Why are we even talking about it today? Well, if you've been following along all of our webinar topics, starting with 3D Printing 101 and then several 3D Printing 201 webinars so far, you probably have an idea of where 3D printing excels. When does it make sense to use 3D printing? And when does it make more sense to handcraft something or cut it on the CNC mill or lathe or cast it? And all of those driving factors that push 3D printing and the other applications that we've talked about, they're still applicable here. So while I was doing my research and coming up with user cases, I noticed some reoccurring themes, and that's what I came up with here. So the first reason why I think 3D printing is an incredible use of or I should say, why jigs and fixtures are an incredible use of the 3D printing technology is that when we design for 3D printing, we can use a purpose-driven design approach, meaning we can design a fixture completely 100% functional, and we don't have to worry about how we're going to create it. Because with traditional manufacturing methods, there's a lot of boundaries put on us in terms of getting parts created affordably and timely. So we're usually given a set number of shapes, a set number of cuts that we can make at different sizes. we're fenced in as designers. But with 3D printing, we like to say you have unlimited freedom in design. And we see that a lot in the jigs and fixtures. As we go through these examples, I'll try to point out, this is a jig or a fixture that it looks significantly different than you would normally see. The second thing 3D printing has going for it in terms of jigs and fixtures is that we create them low cost and on demand. Stratasys put together some numbers that I thought were pretty telling. They said on average, with the customers that they have worked with, they saw a 40 to 90% decrease in lead time for jigs and fixtures and a 70 to 95% cost decrease for jigs and fixtures. To me, that says that we're going to create more jigs and fixtures if we have the technology available to us. Because again, going back to my weekend warriorness, I do spend some time creating jigs and fixtures, but I also spend a lot of time thinking, wow, I wish I had one. And I don't do it because it involves too much effort or time or expense to create it. But with 3D printing, the effort, time, and expense are all decreased. And so we're more likely to do it. It goes from something that would be nice to have to being a priority. Third thing that I came up with is 3D printing is very ergonomically friendly. This is a recurring theme that I've talked about for a while now. Going back to the unlimited design freedom, we can create shapes that are very swoopy, very organic shape, things that would be very comfortable for somebody to hold in their hands. And it doesn't cost us anything extra. Whereas with our traditional manufacturing methods, again, we're working with set shapes. We have flat stock, bar stock, square stock, plate. And then we have to figure out how to use those shapes and assemble them using the different types of bonding or adhesives or fasteners that we have available to us. With 3D printing, we can kind of just design it exactly how we want it. 3D printing is also easily iterated or updated. So it's not often that we create a part correctly the first time, especially something like a jig or a fixture, which is designed in anticipation for an action, right? So we can design a part and we could probably envision how we're going to assemble it, how we're going to disassemble it, but we don't know exactly the step-by-step processes ahead of time. So when it comes time to create our jigs and fixtures, we take our best guess, we put them into use, we get feedback from the workers. It says, I'd like it to be a little bit lighter. This is hard to grip. I'm having trouble lining these two holes up. Get some feedback. And because it's 3D printed and because of the cost in terms of time and money is lower, it's more easily iterated. It's also updated. It can be updated more frequently and simpler than if it was a jig or a fixture that had a lead time of weeks or months, which is not uncommon in the world, unfortunately. This next topic is a big one, the idea of consolidated assemblies. We have certain shapes that we have to work with. We can fasten them together. That ends up turning out, we have jigs or fixtures that are assemblies of parts. It might be 5, 7, 8, 10 parts. Again, with 3D printing, there's no penalty for very complex designs or parts. So we can consolidate an assembly of, say, 5 parts into a single part. And there's some benefits beyond just the simplification of the number of parts that we'll talk about later today. And then lastly here, the idea of having digital versus physical storage. Physical storage being your warehouse with shelving and creating a jig or fixture. And once you're done with it, putting it on that shelf and keeping it there just in case you need it again. What we're seeing our customers do now is move more towards a digital storage system where they print out the jig or fixture straight from the STL file, so there's no drawings involved. They use it, and then if they know they're not going to use it for a while, say a few months or a year or more, they'll toss it. But they keep the file. And so they have digital storage of these files, and they can access these jigs or fixtures on demand. they can print them exactly when they need them, and they can print multiples if they need them. So those are the kind of the driving factors that I saw and the real main benefits of using 3D printing for jigs and fixtures. So again, as I was going through this, I had a lot of examples to pull from. There's a lot of info on jigs and fixtures out there on the internet. I kind of grouped them up into 3 different categories: assembly, inspection, and transportation. They're not 100% rock solid. So there's going to be a little bit of, examples that could fit a couple different categories, but we'll start out with these. So we're going to cover each of these very briefly here. Assembly, we got our trim templates and drill guides and masking and positioning and assembly aids. These are the jigs and fixtures that would actually be used maybe in the assembly line. These are the types that I'm usually making at home to make my life easier. The inspection category is probably a category that's going to ring more true with the Q&A people out there, quality assurance fields, people who need to do a lot of testing on the parts, measuring with the CMM machines, and then a little bit of assembly line as well with those go, no-go gauges. And then the last category I came up with is transportation. It's really all about moving parts. So carrier trays is something I had personal experience with, end of arm tooling as well. And then there was one cool application that I came across, and I put it in this transportation category because it was the only one left, but it's not a good fit because these cooling fixtures literally don't move the part at all. So transportation in the sense that you're traveling zero distance maybe. So we're going to talk a little bit about each of these. And again, if you have any questions, be writing them down and shoot them over to me in an email, which I'll give you at the end here. So assembly category, starting with the trim templates. If you watched the composite tooling webinar, I touched on these a bit here. Trim templates are all about making repeatable cuts in composites, so things like carbon fiber or fiberglass or Kevlar fiber, plastics, foam, or even metal. The reason you would use a trim guide is to make, again, precise cuts, but really to eliminate the need for, like, say, a drag knife machine or a multi-axis router. Because if you can avoid using those, it's less machinery you have to buy, especially if you already have the 3D printer for prototyping purposes. But also you avoid the amount of time that would be required for the CAM programming. So looking at a couple of examples here, the one in the top left is used to cut some carbon fiber ply. It's just a simple 2D cut. That would be a drag knife application. But you can see that jigger fixture. That's that's very ergonomically shaped. Looks like it would be very lightweight. Especially something to keep in mind here is that most of these examples are printed with FDM technology. And with FDM, we can control the density of the prints. So something like that wouldn't even have to be solid. It could be quite sparse, very lightweight. The 2 examples on the bottom, if they were trimmed along all in one process, those would be multi-axis trims. So particularly the one on the bottom right, you can actually see how the guy's using it. He's running the tool up against the guide, which is exactly what you'd expect. It looks like it's a little air saw. Most likely, he's trying to make that cut normal to the surface everywhere. And so that would actually be a 5-axis cut if it was done on a router. Now, depending on the throughput, if this guy's doing 1 of these a day or 5 of these a day, it doesn't make sense to track down a 5-axis router and pay somebody to do the programming to do that many a day. So that's where jigs and fixtures come into play. There's always a balance between the human element and the robotic element. And in a lot of cases, probably the majority of the cases, you prefer to to have a human do the work because it's, you keep people employed for one, but it's also cheaper, right? But we also require that they work very precisely and accurately. And the only way that you can have the best of both worlds is with these jigs and fixtures. Drill guides. Drill guides was one topic that I found a lot of examples on, so I kind of had my pick as to what images I showed and what I wanted to say about them. Drill guides are all about accurately positioning and orienting the holes, again, without CNC machinery. So one thing that's often overlooked with holes is that they have a position, but they also have a direction. And so it's not just enough to get the drill bit centered where it needs to be. It actually has to be in the proper XYZ orientation as well. And that's where having a drill guide comes into play, because these drill guides have depth to them. And so you can only use a drill bit in a certain direction right through the drill bushing. That comes into play a lot. So we've got examples from the medical field and the mechanical field listed here. Medical field is pretty interesting because of the shapes that are involved. Most medical applications the models come from scan data and are read in. So the complex surfaces, 3D printing doesn't care. We can mimic those surfaces exactly. So actually the jig would snap right onto the teeth. So in that image in the top there, it's something for the oral surgeon to drill some holes into the jawbone so that they can do an oral implant of some sort. What we were doing previously is the surgeon would get into the person's mouth or other parts of the body. We use jigs and fixtures all through the body with hip implants and knee implants and all throughout. But in this particular case, he'd go into the mouth and he would position the drill as best he could and drill as accurately as he could on his own. But now we have this snap-in fixture with bushings. He's going to drill precisely. Those bushings were placed in CAD. They were placed in 3D, so they were positioned exactly, customized to his jawbone. We see a lot of cut guides as well in the medical field. So I could have added a medical application in the previous slide. We probably wouldn't have called it a trim guide. We probably would have called it a cut guide or a saw guide. But again, when surgeons have to go in and cut away bone, more and more they're bringing in a 3D printed fixture with a cut slot so that they place their cuts as accurately as possible. With the drill guides, it's normally very important to have high conformity to the workpiece contours. So obviously we have that in the organic mouth there model, but we also have it in the mechanical models, which is important. You know, the thing here is that we're building these fixtures directly from the STL file, and we're building the STL file directly off the end-use parts. So designing these fixtures is almost trivial in the CAD side. I was actually going to show the design, go over it inside SOLIDWORKS, but again, I'm a little bit pressed for time today, so that will be another webinar topic. Masking fixtures. This was a pretty interesting application. I had thought about this, but not too deeply. It's the idea of printing physical parts to cover, printing parts to physically cover areas that are going to be sandblasted or bead blasted, or parts to hold tape lines. The application I am showing here, I pulled from a company called Materialize, which is a pretty big service bureau out there. And they partnered up with Audi. Audi came up with this new car that's going to be painted two-tone. You can see the red and the white there. And it's a two-step process. And so they paint one color and then they have to mask off and paint the second color. And they were having problems masking the area accurately and in time. So they teamed up with Materialize to design and print these tape guides, these yellow tape guides with the handles inserted there. So again, we're talking about high conformity to the surfaces. They already have a CAD file of the car. They can build these guides to fit right up to the surfaces. You can't see it in these photos, but these tape guides actually have magnets embedded into them. So they snap right to the body panels and form this nice tight seal. They're bright yellows, so everybody knows that they're there and they can work around them. Pretty good idea. Positioning tools. Positioning fixtures are there to very stably position a fixture or a workpiece. A couple of these images we've seen before. The top two are from BMW. I like the first one in the top left because, I mean, you see it and you instinctively envision yourself grabbing that fixture, right? I mean, it's designed so well with the human factors in mind that you're almost compelled to grab it. Looks comfortable to use. And whoever's using that throughout the day, where they're placing hundreds of these badges on the backs of the BMWs, I'm sure they're very grateful for how it's shaped. This is an updated version of an older design that was not 3D printed. And for the life of me, I could not find a photo for this webinar. But I've seen a photo of the past design, and if you could picture basically a U-shaped part made out of aluminum plate with very thin metal handles to grab onto, that would be exactly what they used to use. So it's very uncomfortable looking. It looked like it was quite heavy, where this Stratasys and BMW determined that they're about 70% of the weight of the equivalent aluminum fixtures. So that's very comfortable to use throughout the day for that worker. The one on the right, top right, is also a BMW fixture. And to me, that just speaks, the design of that just speaks so well to that unlimited design freedom. You know, the purpose-driven design. That's a fixture to help them attach the mounting hardware to the bumpers. And so you can just tell they worked from the need or the purpose backwards. The need or the purpose is the positioning of those 3 magnets or 4 magnets that we see. So they started out with those positions and then they work backward, adding everything else. And they can do that and they can get away with it because they don't have to worry so much about the manufacturing. Again, the next one that I like to talk about is the one on the bottom left. It's so simple, so simple. You know, it's just a few different parts laid out in a grid with a fixture cradling them, you know, perfectly conforming to the shape. Something like that would be very difficult to create otherwise, so you wouldn't do that same design. But with 3D printing, it's so trivial. Something like that would take less than 2 minutes for, say, a slightly more experienced than a newbie SolidWorks user. It would be very simple for almost anybody. Okay, so when I got to this category, assembly aids, I didn't feel so clever for using the assembly fixtures title, because how can you have an assembly aids subcategory underneath assembly fixtures? It's the same thing. So my process broke down a little bit here, but work with me. So assembly aids are fixtures used to help in the assembly of parts. You know, you have several parts that need to be assembled together, either fastened or bonded or screwed, all sorts of things, right? So they need to be assembled. And so it's all about work holding. You know, some sort of custom work holding to align these parts and place them in the position that you need them to be. The example there on the left with the arbor press, I think is pretty cool. It comes from a Stratasys customer. The company is called Premier Source. It's a small company. I read that they had 27 employees, but they have 2 Fortis machines. And they're one of those companies that started using the Fortis machines for printing fixtures, and that has become one of the primary uses of the machines. You know, I'd say the majority of people come into the machines thinking they're going to use them for prototyping. And then again, as they start to use the machines and become more comfortable, they start to pick out more and more applications around the shop. And one of the easiest ones to gravitate towards is jigs and fixtures. But the nice thing about that arbor press fixture is, again, it is definitely custom. It's custom fit to their arbor press. It's going to work for them for a long time, especially since it's made out of Ultem there. The middle one is a assembly aid printed out of ESD7 material. So ESD is electrostatic dissipative material. It's great for plastics that are going to come into contact with printed circuit boards or anything that is sensitive to static shock. So this is a perfect scenario. They've got, looks like that's some sort of hard drive assembly where we've got a space for screws. We've got a space for the hard drive enclosure, the printed circuit board. We've got the part names printed in there. So the assembly is going to be, quite simple. And then the last example is my favorite because it's something I printed from home. It's a pair of soft jaws that I use for my benchtop vise. I've been working on my car recently, and I've been using a lot of AN fittings. So an AN fitting, if you've seen a show car or you've picked up a muscle car magazine or an import magazine, you'll see these stainless steel braided hoses. And the hoses themselves are braided, and then the ends are usually aluminum, anodized aluminum. A popular color would be blue and red. So you have to assemble these hoses yourself, and it takes quite a bit of force and torque to stick these end fittings on these hoses. They're also meant to be kind of decorative, and like I said, they're anodized aluminum, so they're quite soft. So companies will sell specialized aluminum soft jaws, shaped exactly like what I have here, and also aluminum wrenches to help you put these parts together without scratching them. And I have the printers here, and I use them as I can. So I designed this up in SolidWorks pretty quick and printed out a set of soft jaws for myself and a wrench. I put a couple cavities on the back of the jaw there so that it would stick to the vise. I thought that was clever, but again, that's something that is actually used a lot more often than you would think. The idea of using magnets with these parts. But it helped me do the job, and I didn't have to spend any extra money on the custom size wrenches and whatnot. That particular part is made out of ABS, and I used it to assemble hoses anywhere from -4 to -10 size. So a -10 size hose is pretty hefty, and I probably made 20 hoses, so 40 fittings, and I had to redo some of those as well. So it probably lasted me 60 or so before I finished the car, and I ended up tossing it. All right, so that kind of does it for the assembly category. Let's hop into inspection fixtures. So these are our Q&A fixtures. Testing would be work holding for either your functional or destructive testing, meaning the part already exists and you got to get some data from it. All right, so these parts can be held. The parts can be held to the fixtures, either with friction or, in the case of the top left, just gravity because it's just sitting on top of it. Fasteners, screws and bolts. Magnets, like I just mentioned, and also a vacuum. So the example on the top right came from a company called ITW Transtech, and that's a vacuum holding fixture. So it holds a clear lens that is placed on that 3D printed part, and then they pull a vacuum underneath it, and it holds the part. I thought that was pretty slick. That's not an FDM part. That's a part created with another technology that is a little bit less porous than the FDM. The polyjet technology would be able to use for that scenario. So speaking of fasteners and magnets, it's not uncommon to see people pairing off-the-shelf hardware with these prints. Again, another example from that Transtech is on the bottom there. We got an adjustable fixture riding 2 steel rods. So that can be adjusted to fit several different parts with a single fixture. I like that. I'm going through these examples. I can kind of tell which are the older examples, which have been around for a couple of years, and which are the newer ones, because people are getting a lot smarter and more clever and creative with using these 3D printed parts. And I really like that example, sliding on those steel rods there. All right, measuring. So this is still the Q&A guys or gals. So instead of putting a part in the fixture and testing it or breaking it or putting it in some sort of functional situation. Here we're just measuring it. All right, so this is basically a CMM process, but it could also be other measuring types. And, your primary concerns are going to be accuracy and repeatability. We want to be able to replicate our testing, and we also want our testing today be the data that we get from our testing today be interchangeable with the data that we got 2 months ago and 6 months from now. So FDM is a great fit for that. At the beginning, we talked about consolidation of parts, eliminating fasteners. That's a big thing in the measuring category, because anytime two parts are fastened together, pulled apart, and then fastened together, if you don't put any thought to that process, those two parts aren't coming back together the same way they were before. And, unless you pin them and you are consciously measuring them to make sure that they come back the same way, they're not going to. And so when it comes to measuring and this idea of having repeatable results and good data, if you have a fixture that can be taken apart and reassembled, if you're doing that haphazardly, you could actually be feeding yourself some really bad data. So take, for example, that image on the bottom left where we've got some stepper motors and pneumatic cylinders all aligned orthogonally. The traditional design for that would probably involve a lot of aluminum plate or Delrin plate that is fastened together with screws, maybe screws and pins if you're thinking ahead. For storage, you might take that apart and put it back together. In a shop environment, again, you take something, put it back together. Who knows what sort of metal chips got in between there? Who knows if you pinned it or not so that the screw holes are aligned perfectly? Things happen, right? So by printing that in a single part, you eliminate all of those concerns. That's kind of where I'm getting at there. The rest of the three fixtures are all CMM fixtures. The two from the top came from Materialize again. They have a product line called Rapid Fit. That's actually a patented product that you're looking at right there. It's supposed to be this modular fixture creation system, and it looks awesome. So they've actually partnered up with a lot of automotive OEM companies to create fixtures for their bumpers. Companies like McLaren and Ford and Lamborghini all work with these guys. So their fixtures are actually a combination of printed parts and off-the-shelf parts, which I like because 3D printing doesn't make sense for everything, right? It makes sense for very organic shape, very complex parts. And that's what they've done here. They've used some plate, they've used aluminum extrusion, and then they've used printed parts to actually made up with the part that they're measuring. Neat thing here is that they can completely design their fixturing around the important CMM contact points. They can also create very physically large assemblies without a lot of printed parts, and the aluminum extrusion is just cut to fit. So it's off the shelf and very easy to use. The example on the bottom right came from Auric. Again, it's another CMM fixture, mates up to a very swoopy shape, very simply. Neat thing that I like there is a little XY coordinate system, and we saw it with the ESD7 fixture as well. With 3D printing, you can include a lot of text. It can be part numbers, it can be SKUs, it can be QA instructions. Anything that removes drawings or documentation that has to be passed along with the physical part is going to increase your repeatability and your accuracy. Go, no-go fixtures. So these are simple pass-fail inspection gauges. I really like this application, but I could not find a lot of examples for it. So we got one image here. I've actually seen this more in person than online, which is very rare. It's normally I'm learning almost everything online through all the different user cases and people announcing what they've done pretty much every single day. Learn something new. These go no gauges are pretty popular. I just haven't seen a lot of them online. Maybe because they're so basic and people don't brag about them so much. But the idea is simple. You hold it up to a part or two parts or three parts. And if it fits, it passes, and if it doesn't, it fails. So the important thing here is that, when these are in use, they're usually used quite heavily, several times a day. So durability is a key thing. Also ergonomics, it has to be comfortable to use. And then also, consistency across locations, meaning if you have, in this case, we're looking at a car manufacturing plant. If you have manufacturing plants across the nation or across the world, you need your tooling and your jigs and fixtures to match up because you don't want inconsistency in your product. And I've been around enough shop guys to know that if a tool like this isn't comfortable to use, they modify it. And if they get to the point where they're going to modify it, it's very possible that they can modify it so that it's actually producing different results in terms of pass-fail than other equivalent gauges around the world. So we don't want that, right? We want gauges that cost so little time and money to create. If somebody needs something different, we can accommodate that. Instead of allowing them to take a die grinder to whatever gauge or fixture they're using, just accommodate something. 3D printing is all about customization. I can guarantee the guy who's using that fixture right now has a different opinion on it than if a small petite woman was using the same fixture, because their hand sizes are different. So it's gonna be more comfortable for one than the other. Makes a lot of sense to actually have multiple fixtures, and we can get away with that because the design of that fixture, you already have the CAD model of the body panels. That fixture is something very easy to design because we don't have to worry about how it's being made. So we just design it for the purpose and nothing else. I also like that particular one is plastic because it works so well. They can put it right up to the painted body panels and they don't have to worry about scratching anything. Where that particular shape right there would probably be a weldment if it was traditionally made. And then you'd have to have some sort of soft coating or whatnot. So probably actually a simpler part. All right, transportation fixtures. So this is kind of the last category here. Carrier trays is the first one I came up with, and this is something that I have some personal experience with. Working for a company that did some in-house assembly, and me personally designing some assembly stations. Half the battle was getting the parts to and from the station that you were designing. So if that wasn't hard enough to figure out how to, say sandblast a part and get it fed in and whatnot, I actually had to get it to the next station as well. And sometimes that was going to be automated and sometimes it'd be done by a person. But almost always what we did, especially for the more complex shape parts, is we created trays. Something that could be very easily stacked, and the parts when they're on the tray would be nice and organized and nothing would get mixed up and allow the workers to sort them and whatnot. Those trays were kind of tricky to design because we were always trying to design them in ways that were easy for the machine shop to cut because we didn't want full 3-axis, 5-axis surfacing on these trays. All of that kind of goes out the window if we had been using 3D printed for those trays because, again, inside the CAD system, creating something that's a perfect form fit, almost trivial. We can create trays that perfectly cradle a part, and it's not going to cost us anything in terms of design time and manufacturing time. So carrier trays are pretty common in the assembly line scenarios. Also custom packaging or supports for shipping long distances. So, I'm talking about transportation here. That transportation might be a few inches, 2 people sitting right next to each other in an assembly line, or it might be transportation across interstate highway, and we're worried about parts breaking along the way because they're fragile or they're one of a kind. So custom packaging and supports for the shipping crates as well. There's a couple examples I came across. End of arm tooling. This is an awesome application. Not just because robots are cool to read about and to use, but it actually makes a lot of sense. So this whole time we've been talking about jigs and fixtures for human use to make humans more repeatable, more precise, but robots are already that. So what does a robot need a fixture for? Well, we could push them to the limit, higher throughput. Instead of a robot grabbing one part, we can allow it to grab 10 or 20 parts. We can also do this with plastic tooling. So, unfortunately, robots aren't perfect, mostly because humans are still programming them. So when a human programs a robot, say a 6-axis robot like what we're looking at here, it's hard to anticipate problems, but they do occur, and you crash robots. Nice thing about plastic tooling on the end of a robot instead of metal tooling is that plastic gives, plastic breaks. There's no shock load for the robot, no destroying the encoders or having to get them recalibrated and whatnot. So I like the plastic end effectors, end of arm tooling a lot. I also like it for the fact that figuring out how a robot is going to grip and release a part is extremely difficult. I've been in that situation before, and nothing I really tried worked. Mostly because I was trying to use mechanical means. But especially now with, say, vacuum lines and airlines, we can do a lot. And with the flexibility that 3D printing grants us for the design of those fixtures, it makes the engineer's job a lot easier. And last but not least, the cooling fixture, which is part of the transportation category but doesn't move at all. The whole idea here is that when you have a large injection molded part, it tends to, it takes longer to cool than a small injection molded part. So you're not running these every 5-10 seconds. They actually take quite a bit of time to cool. And when they cool, based on their large size and also the fact that these tend to have a little bit more variation in their wall thicknesses, they warp. And so what a cooling fixture is something that you take the injection molded part fresh out of the machine, you place it in the fixture and lock it down and let it cool until it gets to room temperature, and then it's safe to remove it, and hopefully you've avoided any sort of warping. So these are normally very physically large fixtures, and they can be quite complex in the design. So this image here, you can see the complexity. It's actually a lot more complex than a typical fixture would be, because the designer had that flexibility. They had the ability to design however much complexity they wanted into it. You can guess the size of that because one of the images has a roll of masking tape in there. We've got those toggle clamps that most people are familiar with. These parts, it looks like it's probably printed in one part, but it could be printed in several and then bolted together with the fasteners. Those toggle clamps are bolted into the fixture. A lot of times we use threaded inserts for those instead of screwing right into the plastic, but either one works. If you want it to be strong and you want to be able to remove and reinstall a toggle clamp or the screw itself multiple times, you usually want a threaded insert there. So cooling fixtures is the last example I came across here. So that about does it for this 201 Jigs and Fixtures webinar. Again, there was a lot of information out there. I could only present so much in this webinar, so I definitely encourage you guys to go out and do a little bit of your own research into the jigs and fixtures. And if you're in an R&D setting or any sort of setting where you're creating parts, look around you and look at what jigs and fixtures you guys already have laying around. What jigs and fixtures have you thought about making, but you didn't because the amount of effort and time and expense that goes into it was just not worth it to you? Be thinking about those and maybe run a couple ideas by me. I'd appreciate that. And again, if you have any questions, shoot me an email, treed@goengineer.com. I'm going to upload the slides and we'll put a link to download them in the About section on the YouTube page. All right, so look for that if you want them. And I'll see you guys next month. Thank you.